نتشرف ببلادي ونتشرف بأصلي وبيكم بالكل. Vraiment, je suis très très honorée d'être votre invité. Je suis très honorée d'être en compagnie de Sami ou bien sûr et les femmes incroyables. J'ai découvert tellement de talents عندنا في تونس.
Évidemment.
Les femmes et les hommes aussi. Mais حبيت أعطيكم شوية un background علي أنا. أنا bien sûr je suis le produit de l'éducation tunisienne من الأول راهو je suis la génération de Habib Bourguiba معناتها الله يرحمه. Cette éducation était vraiment excellente معناتها vraiment ما عندي ما نقول فيها معناتها je suis vraiment le produit de ce système-là. Il était un système incroyable, نجم نقول لك competitive with the whole world. Donc أنا نجم نرى نفسي معناتها I was a seed معناتها planted in Tunisia و flourished into a flower and in a fruit والفروت كان باهي و healthy. بالكدا في تونيجيا I went to an all-girls school in Tunisia معناتها lycée des jeunes filles du Bardo وقتها في خزنة دار. Donc c'était un autre environnement qui نبدا نقرا كل كان مع البنات وكل c'était pas la même chose que وقت اللي جيت لوني معناتها وقت اللي جيت في امريكا. نجم نقول لكم la plupart des classes اللي كنت نقراهم لي كور كنت انا j'étais la seule fille معناتها dans ce milieu là. Donc c'est un grand changement معناتها نعرف انتم حكيتوا على هذايا شويه قبل. Mais شنو اللي صار معناتها شنو أنا le produit de quoi? Je suis le produit de l'éducation tunisienne et aussi l'éducation, les hautes études américaines et surtout l'environnement de recherche. Donc كيما قلت بديت أنا j'étais I was a seed معناتها كيفاش نقولوا معناتها الحبة اللي بدات معناتها البذرة هذيك وولات الفلور و un fruit في تونس. كي جيت لأمريكا نجم نقول لكم peut-être la meilleure analogie كاين واحد حطك في صحفة وليت avec salade de fruits ما عادش أنت برك معناتها الغلة برك مع برشا غلات أخرين خاطر هوني ثم c'est un milieu multiculturel très très divers. It's a diverse multicultural system وهذيك it's very very important for creativity معناتها هوني ils peuvent attirer les talents de toutes les sources معناتها de partout dans le monde. انت تاخذك الفروت سالاد هذيك dans l'environnement هذاك معناتها تبدل كومبليتمون النكهه تاعها. مي من لوين دو سا معناتها حتى نجم نقول ابري بيان سور خدمتي في dans l'académie معناتها كوم بروفيسور وكل شيء توا نجم نشوف نفسي الحق je suis معناتها هكا au delà de la salade de fruits نجم نشوف نفسي انا كأني un arbre. Je suis un arbre. علاش توا je commence à donner, je commence à éduquer la génération de l'avenir. Donc c'est ça à travers mon laboratoire de recherche et surtout alhamdulillah mon laboratoire a produit plusieurs générations déjà de scientifiques et de chercheurs. Ils sont partout. La majorité, bien sûr, ils sont ici, dans les États-Unis. Ils travaillent comme des chercheurs, machine learning engineers, data science engineers, research scientists, des professeurs partout dans le monde et partout, en Silicon Valley et surtout, etc. Donc l'arbre a commencé à donner des fruits et donner faire un impact, to make a social impact on the future. So this is, I just wanted to give you an introduction, Hakia, and also again to thank you again, and I'm very, very honored for your invitation. And I wanted to really thank two people who have made an incredible effort to help me with the slides. Khalil Damaq, for his superb help with the slides and so many graphics. These are students in my research lab, by the way. They do much more than slides. And I will tell you a little bit more about what they have done. And Sami Khanisi, for many of the graphic elements. We know Sami is the artistic and the graphic designer gifted student in our lab, in addition to his scientific excellence also, as well as Khalil. And I'll tell you about more of my team. These are starting from the most recent ones. These are all students that have gone through my lab, and I'll go over them maybe in the end if we have more time. As you can see, we are a very, very multicultural team. You can see here I have a dual citizenship, so that's why I have, and as I mentioned, right, I'm the product really of both Tunisia and the United States, and many of my students become dual citizens also in the, as they settle here and they work and so on. But most of the students, they come from so many different countries. They come from Tunisia, from Iran, from Saudi Arabia, China, Russia, Palestine, and the United States, of course, Algeria, Egypt, Colombia, and I hope I didn't forget anyone else. And also Fulbright scholars. I have had the honor to host 3 Fulbright scholars in my lab, 1 from Tunisia, Kuthair, and 2 from Colombia and South America, Fabio and Jonathan. So just to give you an outline, I'll talk a little bit about the general research focus in my lab, and then talk about the fundamental research, and then applied AI and machine learning research. And then I'll finish a little bit with some outreach, like how does my lab make a social impact, maybe a little bit beyond just the academic setting, right? So talk about how we interact with high school and middle school teachers, for example, to have an impact on children. So this is really from a brochure, by the way, of our lab. So here you see that it's called the Knowledge Discovery and Web Mining Lab. It was named more than 20 years ago. So knowledge discovery, meaning that we're trying to advance machine learning and data mining to discover knowledge from big data. And we build tools to try to investigate and analyze value from usually heterogeneous and large data sets. Web mining, it's because really our focus from the beginning has been mostly on mining the internet using innovative technologies. And our main focus has been especially web usage mining and recommendation system algorithms. And we also do a lot of community outreach. I'll give you an example of that in the end. And right now we work a lot on explainability and I'll tell you more about that, of course, in a minute. And that means trying to build machine learning algorithms or AI algorithms that are able to explain their prediction. And this is part of the whole area of fairness in machine learning. So when I talk a little bit later, I'll also mention bias and as well as explainability. Both of those fall under the umbrella of fairness, right? And we do big data for the greater good. And what that means is sometimes we use our machine learning algorithms to solve challenging problems in society that have an impact on improving the quality of life and improving society in general. So really for the greater good. And our focus, I believe we are specialized in recommendation systems, really in all aspects of recommendation systems, from how to deal with multimodal data, to how to deal with streaming and evolving data or data streams, to how to include this idea of fairness in AI in recommendation systems, where it's extremely important, as I will show you later on, because it can, recommender systems have been shown pretty recently, unfortunately, that they can cause polarization, right, and bias. And we believe in my lab, you see here the quote by Margaret Mead, that never doubt that a small group of thoughtful, committed people can change the world. Indeed, it is the only thing that ever has. So each one of us makes a difference, and we all make this small increment, and together we hope to make the world a little bit better. This is just the contact information that I will also have at the end of the slides. And here I'm showing you like a panorama of this. I know this is too much information, but occasionally our school asks us to give them one slide, just one slide, that kind of summarizes our lab. And this is the slide that I have at this point. It's impossible to put everything we work on or every project we have worked on in the past, but these are some sample projects that we have really had the fortune and the honor to work on. One of them here has been funded by NASA, and it's about mining coronal loops from solar images. We used real data from 3 different kinds of satellites to be able to mine coronal loops automatically, right? And this was something that we did in collaboration with physicists. And the other project right here is funded by National Science Foundation. It's about algorithmic bias, and I'll talk about this a little bit more, especially in how humans and AI algorithms interact with one another. And the best setting where that happens, actually, that human in the loop kind of setting, it turns out it happens naturally in recommendation systems, which is why recommendation systems are what we work on in general. And that number 3 here is social media mining from noisy data streams to stories. We worked on this a lot, especially with the, at the beginning of this word called big data. At the time, it was a big buzzword, and social media and so on. And we were able to use machine learning and AI to basically mine raw data from Twitter in this case, and literally come up with stories out of the data. So we can literally have stories. For example, this is just showing an example of a story actually coming from a basketball championship game that University of Louisville won at that time. In case you didn't know, Louisville was the champion at some point, 2013, the national champion. And these are like milestones and so on. Number 4 shows explainability by design, which is a concept that was invented in our lab, and I'll talk more about it also in a minute. And number 5 is another example of showing text mining. So we use text mining of medical articles in order to discover a gene interaction network for glaucoma, which is a very debilitating eye disease that leads to losing eyesight. So let's get into more of the AI side and the technical side of this, right? So what is the focus of our lab? If I were to say what it is, right now, it is the 3rd wave of AI. I'll go back, if we have time, and tell you what we have done in other waves, right? I believe we haven't done much in the 1st wave, but we started in the 2nd wave and moved into the 3rd wave a few decades ago. So the 1st wave of AI is generally understood as reasoning over narrowly defined problems, but with a poor level of certainty. So we're talking about being able to encode handcrafted knowledge, rules, and so on, and expert systems. So many of us, people from older generations probably are familiar with expert systems, right? So what is the 2nd wave of AI? 2nd wave of AI really is based on creating statistical models, right? So training them on big data, right? This includes things like machine learning, data mining, and deep learning, and so on. And the 3rd wave now, what does it mean? So here in the 3rd wave of AI, we want machines that not only can learn, right, given a static data set, but can adapt, to changing situations or changing domains, right? Machines that are able to be aware of their own limitations, right? Hopefully they know when they're good, their predictions maybe should be trusted or the other way. They're able to interact with humans, and this is a big deal right here. And that's because we now see AI and machine learning really starting to permeate societies, really in all the sectors, right? And so there is no way to isolate humans. And I mean all humans, not just experts and scientific researchers from AI. Really, everybody is affected by AI and affects AI. And so there is a big need for fair, unbiased, and explainable AI and machine learning. And that is really where most of our research is situated right now. It's in the 3rd wave of AI. And this idea, 1st, 2nd, 3rd wave, by the way, was coined by DARPA, and there is a link there to video. So now, to say this in a very simple vocabulary, right? What is the difference between 3 waves of AI? Imagine here going from left to right. Wave 1, you're just trying to describe information, right, and data. Wave 2, you're now trying to categorize it. So you're able to possibly say that, this picture is a picture of a bird or of a cat, right, and so on. Or you're able to categorize that maybe, this robot is about to perform a task. Is it going to most likely fail, or is it going to succeed in making that task? Wave number 3, the last one, is explanation and also contextual adaptation. So you see the difference here going from wave 1, 2 to 3, right? We're going from mere description, right, to categorization, which is, of course, a higher level of intelligence, and prediction, by the way. So categorization comes with prediction. Most of the time, I could have just said predict there. Then on to the third wave, which is explain. And that is where we're talking about contextual adaptation. So, in the third wave of AI, right, we do two kinds of activities. We work on fundamental research, and that means algorithm development. So we design algorithms, for example, in explainable machine learning here, right? So we take black box machine learning models, which are, of course, the most advanced in terms of the state of the art and the most accurate, right? However, they are black box by definition, which means they cannot explain their predictions. And we try to add explainability to them, or we try to make them explainable. Number 2 is recommendation systems. As I mentioned before, recommendation systems is a big deal, and our lab has been really forever. And here we try to address different challenges in recommender systems. For example, how to deal with heterogeneous data, sparse data, right? Cold start data, evolving interests, right? And special domains, right? And of course, explainability, I mentioned it above. And then third is bias and fairness in machine learning. And that is a big deal of what we do right now. And here we work, for example, on detecting feedback loop bias in recommender systems and on studying and building fairness. And there is a fourth axis, which is explainable clustering algorithms and applications, where we're trying to develop deep clustering algorithms while also building in explainability. We also apply machine learning algorithms. So now, whereas in fundamental research, we literally create something new, brand new, that did not exist before. And we prove, of course, through scientific experiments and theoretical study, right, that it outperforms the existing state of the art. And we also, of course, do theory to try to understand phenomena, right, and that emerge as part of the AI ecosystem. In applied, on the other hand, we apply machine learning and data science research to solve other people's problems. I call it sometimes other people's, and this is usually, we are approached here by other teams in general, people from the medical domain, people from the physics domain, and so on, who come to us and say, I have this big, huge problem. I have heterogeneous data. I have this, I have all kinds of different data sets, and I want to find this. Can you help me, right? And this is where we work on designing data science pipelines. For example, in the case of autism, right, to help detect hidden patterns with patients from medical history data. We worked on projects for child abuse detection, and here we use the data, it actually is coming from autopsy and medical reports of dead children, to build a data science pipeline that helps detect, did that child die of an abuse or not? Literature text mining. Here we're talking about mining the medical literature using text mining techniques to build gene networks associated with a certain disease. So as we know, a lot of the traditional work in genomics, right, and the medical research is based on actual, working with patients and doing, lab experiments, in vivo and so on. And what we have done here is something at the time was actually pretty revolutionary, because it was the first gene networks for the glaucoma disease, which is an eye disease. And the idea was, in this case, to mine the medical literature. So we're looking at papers, just text. So we're doing text mining to extract from that text what has the community, in this case, close to 9,000 articles, right, of publications from the medical domain. What has the community found and discovered over decades and decades of research, right? So give me that, and then, trying to find maybe parts of the gene interaction networks that were not known before, that are not in the current databases of gene interaction networks. And I'll show you examples of what we found out. Also, of course, other domains. So really what you see here are different problems, different domain. We worked on with education specialists also to use data mining to detect patterns. And finally, there is another project on explainable machine learning for robot prediction. Sorry, I need to make sure to turn this on the do not disturb. So explainable machine learning for robot failure detection. And here is the example I mentioned before, where we're trying to detect impending failure or future possible failure of a robot before it happens. And the reason we do this, again, this is actually part of the third wave also, because robots more and more are supposed to work in collaboration with humans, right? And so since we have humans and robots working together, it really makes it's very, very important to be able to predict what the next move of the robot is going to be, right? Is it going to fail or not? If it's going to fail, maybe we want the human to perform that task instead, right? So let's start with explainable recommendations. So I'm going to start with the fundamental research, just give you some examples of algorithms that we have developed or studied in explainable recommendation, and then I'll go to debiasing and bias and debiasing of recommendations. So we continue this, and then we move on to the applied machine learning and applied AI. So what is a recommendation system, right? Really, a recommender system is supposed to predict a user's preferences to recommend relevant items, which are tailored to their needs. And you may not, even if you're not familiar with the word recommender systems, there is no doubt that you have been using it without knowing it. Because anytime that you were shopping online, you probably were recommended, right, some items to buy, or all of a sudden things show up. Now the data for this is of course a simple toy example, shows users as the rows and items as the columns, right? Assume in this case that one means that this person bought this item. So this person bought this piece of furniture, this person here bought a piece of furniture and maybe a purse. And this guy right here bought a purse and a shirt or a sweater, right? So the idea is the ones show us what they have bought, right? Or maybe what they have liked. Maybe they gave a good rating for it, right? Or maybe even what they just clicked on, right? The question mark is what the recommendation system is supposed to predict. So what is this user going to do with the purse? Would they like it? Would they like to buy it? Would they be interested in it? And so on. And this idea, this simple idea, is extremely important because it is really driving e-commerce and e-entertainment, online education, and actually even on what you see on your Facebook feed, for example, Twitter or Instagram, is driven by recommendation systems, because you wouldn't be able to deal with the information overload otherwise. It's just impossible. So examples here, you can see recommendation examples in the music domain, right? So you may see, music recommendations such as, on Spotify, Pandora, and so on. Of course, we see recommendations for movies on diverse platforms, from Amazon, Prime to Netflix, and so on. And of course, the e-commerce domain, which really started it all, right? Things like Amazon, Walmart Labs, and so on. So, of course, recommender systems are a key component on most modern platforms, from e-commerce to video streaming to music streaming, right? And many other domains, including education. I mentioned Coursera here, right? Social media, news are, of course, what you see is, the first time you go on a web portal for news, you might see the same thing, but as you start clicking and reading, different news articles, you start seeing recommendations pop up, usually in the bottom or somewhere in the middle. And those are actually personalized to your interest. And of course, they are used in many other domains other than this. So it's impossible to constrain them. So we come to the explanations here, right? So why do we need an explanation? And I'll let you just look at this comic and read it. And I'll pause for a minute. So here, the joke, in case you weren't able to read it, says they come to this guy eating a sandwich, and it says Twitter and Facebook could not predict the election, but they did predict what you're going to have for lunch, and it's a tuna salad sandwich, and you're having the wrong sandwich. So the guy is probably having a roast beef sandwich or something like that. And when you have something like this, you might probably think, what is the response of this guy who's eating the sandwich? might actually ask why. Why do you think that way, right? And maybe the recommender system has used data incorrectly, right? Or something like that, right? So this is just a joke, but it's supposed to illustrate the idea that, one possible example where an explanation is needed. I'll show you another example here, right? So that shows how explanations can actually help the user make a more informed decision in general. So that is also another impact of explanation. So for example, let's say this guy is recommended to see The Godfather, and why should I like to see it? And you can see the explanation in green here in the bottom. The explanation is because this person liked Scarface, which is related, right? It's basically a mafia movie, right? So the user will put one on one together and get two, as they say. Here is an example here. I like this example because here the recommendation is the bank job. Frankly, I'm not sure I know about what the bank job is. Maybe I know The Godfather and so on. I don't know what the bank job is. I have no idea. Why should I even waste my time and watch this movie, right? And with the explanation, which is shown in green, the explanation in this case says, because you liked Ocean 11. I actually know Ocean 11, and I liked it very much. And a lot of people do, right? And this tells me that maybe I might actually see it. Or if the explanation tells me that something else, by the way, we actually saw examples of explanations that might tell you that maybe not, you shouldn't see the movie, right? If it's a movie that you didn't like. Okay, so going back to explainable AI. So in general, right, we start with data, right? Data goes to AI, machine learning, and outcomes predictions, right? So what explanations do is, of course, add another layer on it, right? So how you do it is another story, okay? So let me just mention an example of an algorithm. Really, it's more like a framework in this case for explanation that was developed in my lab. And the leader for this was Benouche Abdullahi, was a PhD student. She now works in Walmart Labs, doing research on personalization in Silicon Valley. So here is what on the left, what is shown on the left is before, on the right is after, right? So traditionally, this is how recommender systems work, actually. They just ingest data, right? And then you have this big AI model that outputs the relevant items. What is most relevant to you? And those items are usually sorted or ranked from top to the bottom in order of how much you will likely click on them or like them or actually follow the recommendation, whether it's music or movies or e-commerce products or even trip ideas, maybe in the tourism domain or something like that. Now, here is what we have done. And I have given detailed talks about each one of these. By the way, I gave talks about this actually at Netflix and at Amazon and Apple and so on. But I can give maybe a more detailed talk about this, but it's not going to be here because it's just too much. So this idea of explainability by design is basically we use this input data to find, based on the data, right, and the user preferences, which ones of the items might actually be explained before we even build the machine learning algorithms, right? So once we build what is called this explainability graph, we take this graph and we use it to regularize the optimization cost function in building the machine learning algorithm or the AI model in this case. And out comes, explainability, recommendation systems that are able to not only make predictions of relevant items, but they're also explainable. So in other words, improve the explainability. And just the intuition about this basically shows you how it is. This is based on latent factors. By the way, latent factor models are the building block of most state-of-the-art advanced recommendation system algorithms, as well as deep learning models that are used for recommendation systems. So the idea is really, in the end of the day, is taking the humans and objects, right, or whatever, in whatever domain, and projecting them on a new embedding, right, or a new manifold, a new space where the computations become more meaningful. In this case, in the case of latent factor models, you can actually compute how relevant an item is going to be to a person by simple distance measures, right, or similarity computations in this new space. Now, the idea is to take this take the take the item that is more explainable to the user and try to project it into this new latent space so that it's closer to that user, right? And therefore, that is really the magic. And this is showing the details, of course, the flow charts of this. So starting with the data, as I mentioned, we compute explainability scores right into a graph, an explainability graph. Then we use this explainability graph in order to learn a new kind of machine learning model that is explainable, right? So we use the explanation scores to teach the machine learning model not only to make a prediction which is correct, but to make a prediction that is correct and explainable. It's actually a very simple concept, and it worked really well. And I can show you here examples. And the example here is the movies, the top 5 rated movies for a test user, right? And let's say in this case, the recommendation is LA Confidential, which is 1997 movie. And here are examples of explanations. So this is the first explanation is based on rating. So it says that 8 out of 10 similar people to you have rated this movie 6 and higher. We could have just said most people like you like this movie, right? Or it could be based on review sentiments. So we also have explanation scores that were generated by mining the text and the reviews. And in this case, you show the user which specific reviews tell us, right, that why this movie is good for that particular user. So in this case, the acting is phenomenal, right? It's the screenplay is second to none, and so on. We took this idea of explanation by design a little bit further, and we tried tinkering with different ways to design explanations. So I mentioned here designing explanations based on the ratings alone, based on the reviews alone, right? Well, what about using the semantic web, right? So semantic web is basically a huge knowledge graph that in a way embeds information about things. In this case, let's go to the movie domain. In the movie domain, the entities are actors and movies, right? Maybe directors. So knowing things about which actor starred in which movie and which director directed which movie and which writer maybe wrote the screenplay for a movie, right? And then which ones of these you have as a user, which movies you have liked before maybe and watched, right? And then what we do is when we try to explain that recommendation for you, we actually look into this knowledge graph and we try to say which actors you previously liked that actually star in this movie, right? I know, for example, in my case, I go a lot by actors. There are actors that I like so much, I would see their movie, no matter what the movie is, probably. The champion for this is our lab team member, Mohammed Al-Shamari. And Mohammed is from Saudi Arabia. He's actually a professor right now in the University of North Border. This was his PhD dissertation. And to do this, of course, we had to actually mine the web for the semantic data, right? For the knowledge graph, we got a lot of it from DBpedia, as well as user ratings, right? To come up with both recommendations and explanation. And this is just an example of what it means to show semantic explanations. So in this case, you're showing different kinds of recommendations. Let's say for the Titanic, you can show all kinds of different semantic explanation, whether it's actors or producers and so on. Here is another example of explainable recommendation. This one is in the song domain. So a song domain, if you have used Spotify or Pandora or maybe Apple iTunes, you have probably been using some kind of recommendation systems, by the way, whether you know it or not, that is trying to predict which next song to play and so on. So the champion for this is Damaq Khalil. So Khalil Damaq, he's the one who has worked on this sequence-based explainable hybrid song recommendation. And this is a deep learning network that is able to explain why a song is relevant to you by showing you an excerpt from that song, like a 10-second segment from anywhere in the song, not any 10-second segment, like most of the, by the way, most music platforms, they show you usually a specific 10-second segment, which is the same everywhere, including on YouTube and so on. What Khalil's explanation is which 10-second segment is specifically relevant to you. So for example, if you like, let's say you like classical music a lot, and then you get recommended some song that maybe doesn't look like classical music, maybe rock or hard rock, right? Maybe it's one of those songs that is a result of the fusion of classical music and hard rock. There is actually, there are examples of that actually that are really good. One of the examples is Guns N' Roses, and I can't think of the name of the song, but I know Khalid knows it. And for this, he looked at all of this data, actually did quite a bit of mining of big data from MIDI, so content. He actually looked at the content of the songs as well as the user tastes, right, and so on, to be able to build a data set that will allow this. So this is the architecture of the deep learning network. This is a kind of recurrent neural network in this case that shows how this is done. And this is showing how the explainability model works, right? So the idea is to sample 10-second segments from the recommended song and then be able to use the explainability model to make the prediction of which ones, right, which one of these segments actually is the best. And I can actually show you maybe a demo of this very quickly, and then let me know if you don't see it. Or you don't hear the noise. Please unmute yourself, Sami, and let me know. Can you hear the sound?
Yeah.
Okay. So this is the explanation. And we'll do just one more example. So this is the song, and then we'll see the explanation.
Can I trust the way I feel? 'Cause my heart's been fooled before.
Okay, so we're gonna try to skip this to the next slide because, yep, okay. So I hope that was entertaining. And the next thing I'm gonna move to fundamental research 3 is bias and fairness. So here we're moving away a little bit from explainability, and we might go back to it later, and work and look at bias, right? So how does bias emerge in recommendation systems, right? So whereas on the left you see a classical, supervised machine learning setting, this is where AI was born, really, right? Is typically relying on annotators, which that sometimes we actually refer to them as oracle. In other words, they give you, class labels, right? Class labels that are, sure and correct and unbiased class distributions. In the recommendation systems, the users actually don't do that. They're not oracles or experts. So they rate what they want, what they see, maybe even based on how other people have reviewed certain items and so on. And so that leads to completely unchecked labels or data, right? And that leads to this big kind of bias amplification also in the feedback loop. And what I mean by the feedback loop is a loop between the user here on the top, the interaction data, that they generate, and the recommendation system, which is the AI that is learning based on this data, right? Now, remember, this recommender system is also biasing the user because the user sees the output of the recommendation system before their next interaction and so on. And so this is what we mean by the feedback loop. And I have a nice example here designed by Sami, which shows that the users, right, how in this case, in general, in machine learning, we have data, let's say news, let's say how you actually consume the news before the recommendation, right? Using what is called inductive bias in machine learning, your machine learning models are trained based on these items to build a model. So this is RS, stands for recommendation system, by the way. Now, next, oops, I think there is something wrong with my animation. Okay, yeah, it works. So after the training, right, the recommendation systems is going to output recommendations to the users. Because of things like popularity bias, we end up with unfair recommendations. And then the users, don't forget, they're going to keep interacting with these items, right? So they might click on the next news item. They might, if it was movies, they might actually watch and review and give a rating and so on. And then you have this loop basically repeats itself, and that leads to feedback loops. And not only that, the bias, as you can expect, even by intuition, will typically amplify due to this. So this fundamental research line has generated, a variety of work, I would say. So, and different people worked on it. So Wenlong, San worked on this, as well as Samir Khnisi and Mariam Boujelben worked on this. So we also worked with the cognitive scientists. So a lot of this work here, I'm not going to go into the detail, but used concepts from both AI and cognitive science to perform real experiments that showed, for example, that there is an idea called active recommendation that works really well for debiasing recommendation systems without sacrificing their accuracy. Now, I'll show you in a minute what Mariam and Sami have done in this case. So they did the theoretical modeling of the iterative properties of user discovery in a collaborative filtering recommender system. And basically, they looked at the feedback loops that I just mentioned right here and how these actually lead to different kinds of exposure bias. Now, we know the social impact of exposure bias, by the way, includes filter bubbles or echo chambers, also polarization, and even just underexposure of certain items. So you may have, for example, independent artists, their products might not be exposed enough. And that is a kind of unfairness, actually, if you think about it, in the economic domain. So let me see here why I can't. I'm not going to go over the video, but let me talk a little bit about polarization. Okay, so obviously there has been a lot of talk about polarization, especially in social media, right? And in society in the US, it's pretty obvious, right? Especially after the election, the recent elections and so on. I believe in almost every country there is some kind of polarization, and people have always suspected now that social media is actually playing a role. Social media, things like Facebook and Twitter, in a way they filter what you see and they keep showing you actually what you like. That is the idea of a recommendation system, right? All of these, by the way, are driven by recommender systems, which are in their task is specifically to filter from the vast domain of options out there and show you only the few things that you might like. And as you interact more and more with these filters, they learn what you like, obviously, which is what they're supposed to do. That is their intended purpose, right? Unfortunately, by learning what you like and giving you only what you like or suggesting what you like and you acting more and more with that, that generates this idea of, in fact, the feedback loop that I showed before, and you can see how it can lead to polarization. And we showed that it does lead to polarization. In other words, it makes, if we, let's say we name the different groups or communities red and blue or left and right, what it does is actually makes them, go even farther and farther from one another, right? And so there is a team leader on this, which is Masa Badami. And Masa works as a machine learning engineer at Apple right now in Silicon Valley. And her dissertation worked on counterpolarization methods. And basically, where you can make the counterpolarization, you can do it before the recommendation or during the recommendation or post recommendations. Okay, a lot of people have done the work on post recommendations, but I believe in our lab, we have done more work on before and during recommendations. And the reason is because we work on the machine learning modeling, on the actual modeling part of AI. And to do that, she collaborated with Wenlong Sun right here, to build a polarization classifier. So if you're given user ratings, not even content, it doesn't matter what the domain is, right? We're able now to estimate, the polarization score for either users or items, right? So imagine the polarization score is like a temperature in a thermometer that tells you how polarized that item is, right? Maybe a news article or even the user, right? If you have that information, that polarization score turns out to be extremely important. You can actually design new machine learning algorithms that are going to use that to depolarize the items or depolarize the user. And the idea based on latent factors space, so there is this is something that I already mentioned before, right? The idea of projecting users and items in a common latent factor space. The idea really is to take users and items that are, in different polarities in a way, and possibly bringing them closer together so that they can, be recommended to one another. And the results, Wenlong later extended this idea. So Masa worked on item polarization, and Wenlong extended it to user polarization. And so the results showed that these techniques outperformed the state of the art in terms of how much exposure to the other view, to novelty and blind spots without sacrificing relevance. The next thing that we've done, I mentioned before that I'll go back to explainability, and here we went back to explainability, and the leaders for this was Khalil Damak, who worked with Sami Ayari to build in explainability in the state-of-the-art recommendation system that is used for implicit feedback, which is called Bayesian Personalized Ranking, or BPR, right? And I already mentioned the motivation for explainability. So we know what this is adding. It's going to add explanations. But what I didn't mention is the exposure bias in this case. So imagine you have your items right here in this big quadrant. So whether they're exposed or not exposed is the rows, and the columns is whether they're relevant or irrelevant, right? So of course, if they're exposed and they are relevant, right, typically we will see this, right? We will see them. If they are irrelevant, right, we might see them because they've been exposed. The problem is the red box right here. So in the red box, we have items that have not been exposed to the user. The user hasn't seen them, so we don't know whether they're relevant to the user or not, obviously, because they didn't have the chance to rate them or interact with them or anything. So there was a big assumption that the non-exposed items are not relevant. And this is a common assumption, by the way, that is made in almost all the state-of-the-art AI recommender systems, right? And what Khalil did in this case is built in a totally different cost function or a loss function, right, in the machine learning algorithm, a modeling part that takes into account the propensity, so inverse propensity scoring for the debiasing part. This is for the exposure, but also adding the explainability scores that I mentioned before when I mentioned explainability by design much, much earlier at the beginning. So if you can take those explainability design scores and use them in your loss function, you can actually build a model that is going to recommend items that are accurate, right, that are really relevant and explainable. And in this case, what Khalil added also is that they are less prone to bias, which is extremely important for fairness in AI. And the impact of this is really, if we look at, we look at the non-exposed items in this case, or the exposed items, right? So we are able now to recommend some of the items that are not exposed, but that are relevant to the user, right? And also come up with some explanations, as you can see in this example of explainability. So the next axis is applied machine learning, right? And I mentioned several domains where we have done. This is just some of the domains. We have done other applications and other projects, of course, throughout the years, but it's impossible to put all of them. These are the most recent ones, I would believe. One of them is in the medical domain, and the leader for this was Mariam Boujelben and Benouche Abdoulaye. And the work was on medical data. So in this case, imagine you have patients, right? And you have 3 types of data. This is really the challenge. In this case, the challenge is specifically because we have heterogeneous data. Otherwise, it's just an applied machine learning. So it's really, frankly, more than an applied machine learning, because we had to deal with these challenges. So the three types of data, there is something called the ASD. So in this case, we have different phenotypes for each patient. So whether, what kind of clinical conditions they're showing, things like emotion, excessive social awkwardness, and so on. And then there is the unified ADOS data, which basically consists of severity scores that are assigned by a doctor during clinical visit based on how they answered specific test questions. So these are coming, unfortunately, from two different channels, different sources, right? And then what made this a little bit harder is, of course, having also fMRI prediction data. So this is magnetic resonance imaging data, functional magnetic resonance imaging data for both people with autism and control, right? And this work here was done using clustering algorithms. So you can see here the clustering after data preparation. The most important thing that we've done in this project is doing the evaluation by using those external data sources, the fMRI and so on, in order to be able not only to evaluate how good the cluster is or a group of similar patients. In this case, we were actually trying to see how, which patients, conditions are similar. Not only that, but also to visualize what those clusters are about and even map them on their brain, because we had the fMRI prediction. So we could see, for example, that this brain region, right, in this case, is in a cluster 1 or cluster 5 and so on. So the clusters are groups, by the way, in this case, groups of conditions. This is another project that involved text mining of the articles. I already mentioned it before in the example, so I don't have to go over it. The most important part of this is what was discovered. And here the kind of relations, some of them are known, which means we use these for validation. Some of them are new, right? In other words, there is evidence. We were able to verify, actually, in the paper, there is an evidence, but they are new. They were not in the standard databases, right, on PubMed. And some are unverified. The unverified are actually extremely exciting. What that shows is this is something you can only go and verify in the lab. And so what this project shows is here is a gene interaction network that could guide future experiments. Somebody would have to take this and do it in the lab, which is extremely important for discovery. We also did the social network analysis on this on the gene interaction network and divided it into different groups or clusters, and have seen how the different groups are basically interacted, in a way, their topology and so on. So very important, because this is the first gene interaction network for glaucoma. And this is the last one is applied machine learning for robots, for robot failure prediction. And I already mentioned before how robots now, and especially in the future, are expected to work actually together with humans. And so what this is supposed to do is trying to monitor robot performance based on the data, previous historic data of how the robot has been performing, right? We're able to build machine learning models that can predict whether the robot will fail or succeed in any task. And this can send a signal beforehand, hopefully, to the human who's working in collaboration as a team, in a team with a robot, to be able to decide, is the human maybe better able to go and pick this part, because it's most likely that the robot is going to, drop it maybe on the floor and break it. And so this is an example of what is called the pick and place robotic task. But there are many different robotic tasks, of course, anything from driving to something else. Could be in Tesla, maybe wake up the driver so that they can drive the car on their own. So I'll skip over this. And the idea here again is we try to go around this problem of the black box. Black box models are very accurate. This is called the area under the curve, which is a metric for how accurate they are, right? This is a white box model, which is explainable. It tells us exactly which joint and which finger led to failure or success, but it's less accurate, right? And what we were trying to do is achieve a balance between accuracy and explainability, which we have done in this case by adding explainability to a black box model. And I know that I'm almost done, but before I end it, I know that many of you think that, well, this lab has been going on for over 2 decades, right? But really, people have only started working on the third wave of AI very recently. Before, like everybody else, we were working on the second wave of AI. And the only reason I wanted to mention this project right here of the second wave of AI, which is just building a model to make predictions in this case, was just how exciting it is. And this is a work that I had the pleasure to work with my friend and collaborator, John Schmeltz, from the Department of Physics. So she's an astrophysicist. And my previous PhD student, Nurjan Durak, who's working at Sojourn right here. She's building recommendation systems for travel, by the way, in the tourism industry in the Silicon Valley. And this project basically was trying to help scientists to do their scientific study, to solve an unsolved mystery. So there is an unsolved mystery in astrophysics, and I'll say it in really, it's shown here actually in yellow, in briefly. And the question is, why is the solar corona, right, which is right at the surface of the sun, why is it so hot? Why is the solar corona so hot? And specifically, why is it that it's actually hotter than even the inside of the sun, which is really, really very counterintuitive, okay? So in other words, the corona, which is the surface of the sun, right, especially when you have these loops, as you can see here, this is what is called the corona loop. So it's actually the ejection of plasma from the sun, and it loops back and goes back. What you can see here, the temperature along this loop, right, is actually hotter than what it is right here on the surface, which up to that point was completely paradoxical. So people were arguing over this, and so scientists were studying based on what? Of course, they need the data. So there are several instruments that capture multiple images of the sun per day. But there is, of course, a lot of data. So the biggest obstacle for this is actually putting the data together. And not only that, is finding which images have the corona loops, because only a few of those images, turns out, have these corona loops to be studied. And so our job for that, the goal of that project, was specifically to develop an image retrieval system based on data mining, machine learning, to sift through the massive data sets downloaded from NASA solar image databases, and to discover the interesting images that contain solar loops, and which are very, very rare. There are different instruments or different satellites. One is called EIT, the other one is called TRACE, and the other one is called SXT, which is from Japan. And just to give you the big picture in this case, so this shows where the sources of data is coming from, right? And we actually get this. This is all available through web services, by the way, all of this data, right? We acquire the data, right? So you get the image. So there is, various pre-processing steps that are done before the loop extraction. And then the next thing is, of course, to aid the scientist in decision-making. We tell them whether there is a loop, where it's located, and its size, right? And we use that to enrich the web catalog, which allows the astrophysicists, in this case, to conduct their studies. And without going into more detail, this is just showing you some of the examples of the loops, right? So the one on the left side here, just in case you didn't know, this image, this loop, has been named Cinderella by the astrophysicists because it was voted as the most beautiful corona loop picture. So apparently they do these their own beauty pageants in the astrophysics domain as well. So they call it Cinderella. And so this shows just the variety of ways that loops can occur, right, on the sun. And depending on the different kinds of data, this is just one instrument, by the way, and you can see that there's a big variety. And that is what made this problem really challenging. This is one of the hardest problems we worked on, actually. And this is also to show you the kinds of things that make the challenge harder. Is the sun goes through what is called the solar minimum and the solar maximum. So during the minimum, there are very few loops because there is few activity on the sun, but you can see them, right? And you really want to also capture them, right? And this is an example where the loop is on the disk itself. And this is during the solar maximum. You see now there is a lot of activity on the solar surface. The sun is boiling, so to speak. You have a lot of loops, and it does add actually a lot of noise. And this is what our results in this case showing on this interface, that we were able to get more than 82% precision and recall right, by pointing to where the coronal loops occur out of databases of solar images. The impact, of course, is not just helping the scientific domain, right? So as I mentioned before, astrophysics researchers actually need to work on this. And by the way, in case you haven't known, the sun is considered to be a natural nuclear reactor. So nuclear physicists also study the sun a lot. So this has impact on them, but the human impact perhaps is even bigger because coronal loops are related to other solar events that are related to what is called solar weather. So that includes like things like solar wind, coronal mass ejections, and so on. So if you think about it, being able to detect coronal loops in advance may also help detect these solar winds, so maybe characterize them, even their direction better, right? And that in turn helps protect scientists in space and prevent outer outages and so on. And this is just to show you how the sun, this is the sun and its loops. This is, in this case, a solar flare, which is what happens when that coronal loop becomes so active that it ruptures like an elastic band and it breaks and it just throws this huge ejection into space. This is the Earth right here. Thankfully, we have a nice magnetosphere that actually protects us, except around the poles, and that's why you see what is called the aurora typically there, right? But needless to say, right, that solar wind causes a lot of things, right? So geomagnetic storms and so on. And this is just to show you what they cause typically on Earth. So they can cause harm and damage in space and also on Earth. Things like power outages and even pipelines under the ocean. I mean, who would have known this? I didn't know that. And of course, avionics, airplanes and so on. I know I'm out of time, but I hope you forgive me because we started late. Sami, can I just mention in just 1 minute?
Yeah, you have enough time.
Okay, yeah, so thank you so much. But this is just one thing I wanted to mention, that in addition to research, right, and education, so in the lab, we conduct research on really exciting projects, as you have seen, with really tremendous social impact for most of them. But also we do outreach. So outreach, we do it in several ways. Sometimes we host members of the community, and these are like students from all ages, anywhere from kindergarten and preschool to high school into our labs, right? And we show demos of our work and we tell them about all this exciting research. But also we have this amazing project that is funded by National Science Foundation, which is called Research Experience for Teachers. It's for high school teachers, and we occasionally accept middle school teachers when we have spots. These are from the schools in our region, so in our state and maybe the neighboring states as well. And they go into 6 weeks of immersive research experience in big data and data science and AI during the summer. And so they are embedded. Every team of either 2 or 4 teachers every team of 2 teachers, or maybe 2 teams at most in my lab at one point, are embedded to work in the lab along with the students and everybody else, right? And so they learn about research, they learn about the concepts, they go through what is called the boot camp where we educate them about data science in the first 2 weeks, and then we put them in different labs where they get research experience, and also they work on trying to use their research to build new curriculum to use in their classrooms. So they go back to their classrooms, and this is actually showing the picture right here, showing how they use their curriculum, right, their research ideas to build new projects that they use to teach their own students. And this one actually is where we visited. This is me right at that time. I had blue hair, believe it or not. And this is Mariam Bougelbert right there sitting next to me. So my students sometimes help, not just they mentor, right, but they also visit the schools with me. This is an all-girls school at the time. And other dissemination. So we sometimes make presentations in the community. This is in the Data Science Alliance in our city. This is Emir, one of the teachers, giving a presentation. And this is my co-PI, who's an education specialist, right, and a professor in the College of Education, presenting our work. And just to give you an idea about the impact, right? So typically we have 10 teachers every year for 3 years. every one of those teachers actually has impact on 100 students through the different classes that they have. So if you count 10 times 10, that's like 1,000 students are impacted by this actually in almost a direct manner. And that is every year. So we hope that in 3 years of this project, this year is the last one, there will be 3,000 students approximately impacted. And there is other works. I did the mentoring at the University of Chicago, Data Science for Social Good. In 2015, at that time, I mentored teams working on Feeding America, and the other team was on the Australia Conservation Foundation. So these are all nonprofits, and they don't pay anything. Actually, they just come to us with the problem, and we solve that problem for them, basically using data science. And I'm going to skip over this to go to the next slides because I know we don't have time. But just I wanted to end by thanking the Dream Team, many of the current students and the past students who have done incredible research and leadership in my lab, not just in the scientific output and intelligence, but also in their outreach. They have always been with me in outreach when we hosted students and the members from the community and the public to teach them about what we do, and in volunteering, right, and also mentoring the teachers and so on. And these are some of the pictures of us in our lab and outside the lab, right? And these are orchids. And the expert in orchid revival is Khalil Damaq, who learned it from another student in a neighboring lab, by the way. And these are some of our pictures outside the lab because we continue our relationship. I mentor my students all the way after they, long after they graduate, when they are working. So we meet, they come back. This is Essen. She came back and visited us in the lab. She works in Microsoft. And this is some of these, the ones at dinners are usually where we meet, sometimes in conferences. So we meet, we do reunions occasionally, either after, at the end of the week, maybe in our lab, or when we meet in conferences. This is one of those big outreach events. If you can see the pointer here, as you can see, this is the members of the public. So these are like parents, kids and their teachers and so on. And this is me right here. At that time, my hair was not blue. And again, this is part of the outreach. You can see Sami right here in the back, and Muhammad and Anissa, I'm sure. And this is here, we did a workshop. In this case, we taught a robotics team, we taught them Java in over 2 days, I think. This is Behnoush right here and Wen Long. And that is me. And yeah, this is the public. Here is Khalil, by the way, many years ago, and this is Sami. And again, doing outreach in this case. And the outreach, we do it maybe once or twice a year, by the way. That's how it works. And just to end, these are acknowledgements of some of the funding, the funders of our projects, including NSF and NASA, and many other funded projects, both in the past and in the present. And that's the end of my talk. And I hope it wasn't too much or too fast or too laborious.
Oh, no, it's okay for me, I think.
Thank you for your attention, and I'm happy to
thank you very much, Professor Olfa Nasraoui, for this great talk. I want to say that I feel a very nice atmosphere in your laboratory, with nice people, nice, good place to make research. This is why I have like impression. And,
thank you so much. Thank you for inviting me, and I'm really honored.
I just ask the attendees, if you have a question, feel free to ask question in chat or raise your hand. I will activate your micro to feel free to. Okay, we have a question. Manel, go ahead, Manel.
Hi, hello. Maybe you remember me, Professor Olfa from Texas. This is Manel.
Oh yeah, Manel Slocum, right?
Yes.
Yes, of course I
So
remember.
it's a more general question. Of course, it's related more to Rexis. I really appreciate and like how you work on different diverse topics. And I know you also work on responsible recommender system with Sami and other team members and Anissa. So where are you now in terms of social recommender system? Are you more into fairness, diversity, or are you also looking to other perspective from the fact?
Yeah, so we're working, as you know, on the feedback loop bias, right? That has really kept us very, very busy. Most of the work is on feedback loop bias, but recently, as you have seen in Khalil's work, and also Anissa is going to do this, and hopefully in the future, he's trying to combine bias, debiasing, and explainability at the same time, right? Which is really a huge thing. And we're not working that much on social, I would say, but we're happy to collaborate with others who work on that.
I look forward. I also do some work now on explainability. Okay, of course, I think you remember I work on privacy and recommender systems, but I started a new project more on privacy and machine learning, where I will do also explainability. So
yes.
Look forward maybe to meeting you and Anissa and all the team at Rexis, hopefully.
Yes, I'm sure we will meet again, right? We're regulars. So thank you, Manel. Manel is amazing. She's been one of the best volunteers actually at Rexis, which is the top recommender system conference in the world. I think there is another question.
Yes. Good morning or good afternoon, everyone. This is Riyad Sliman from WIDS in Canada. And Mr. Ayari, if you can activate my camera so you can see me. Can everybody see me? Can everybody hear me?
Yeah, we can hear you. Yeah, go ahead.
Oh, okay. Can you activate my camera here? Yeah. Perfect. Okay. Good. Well, here is 21 minutes past 8 o'clock, the Pacific Standard Time. Vancouver, British Columbia, Canada. Greetings to everyone. Greetings, Dr. Nasraoui, and greetings to Dr. Ayari for inviting me to this opportunity. Thank you very much, everyone. My name is Riyad Sliman. I'm the CEO of KGS. And I would like to thank you for inviting me to this opportunity. Quick question here. AI, artificial intelligence, I'm just exploring ways to apply artificial intelligence in the marketplace that we are building, which is specialized in spare parts of everything, not spare parts of cars only. So that's maybe an academic question to Dr. Nasraoui. If you have already applied AI in such field before, or you are exclusively in the teaching and academic area only.
So our recommendation systems, right, the algorithms, right, are actually used in a variety of domains, right? So just to give you an idea where, who applies the recommendation systems, right? So Amazon applies the recommendation systems, and they do have marketplaces. It's probably, I believe, maybe the largest marketplace in the world, right? And so at the root, recommendation systems are just one component of these marketplaces. So a lot of the algorithms that we develop in our lab or that we apply are useful. They're widely available, in fact, for a variety of applications, not just you know, in the academic world. In fact, we work on real data sets, by the way. So almost all of our work is based on real data, whether it's fundamental or applied. In some cases, we do simulations. That's for very early stage research, which is really in its infancy, where there just isn't any real data. So sometimes we resort to simulations, but almost all the examples are real.
Okay. And that's basically an algorithm that is developed by individual professors or developed under the umbrella of the university and shared with the commercial world, like companies, or how it is?
Yeah, there are actually our algorithms are all in the open source domain. So most of what we have is available. So in fact, recently we even published a journal paper to just explain specifically, you know, one of the algorithm suites, the software suites that we have. But you should be able to find everything, especially anything that's out of our funded project, because it's like a duty that we have to the taxpayers, right? So we have data and algorithms are available in the open source. So we don't watch who's using it for what, really.
Open source.
And we also use other people's algorithms, you know, thanks to the open source. That's how we're able to make research much faster. So we take something and we change it, right? And we tinker with it and we try to add explainability, add, you know, debiasing, and so on. So I think at this stage, the software, you'll find more than what you need, actually. The problem is you need a recommender system to recommend which software to use. Probably.
Recommendation system, yes. And the university, like maybe later on in later stage, we are friends in LinkedIn anyways. Maybe you can share with me the link.
Sure. I'm happy to. Yes, I'm happy.
My understanding, an algorithm in programming, algorithm is a stage before coding, right? So you do an algorithm and then you code, right? You convert the algorithm into a programming language. So, so that algorithm is for recommendation, right? Recommend the behavior of the user on the front end as well as at the back end. And then you code it to whatever as per your need, right? To the language that you know, right?
Yeah. So when we share our code, we share it. So a lot of our recent code is in Python. We did have code long time ago in Java, but we changed now where everything we do almost is in Python.
Okay. Yeah, that's it. Thank you very much. My presence here is just to know ways on how we can apply the AI on our sector in particular, and explore opportunities. That's great, and also to see you in person and Dr. Nasraoui. And
thank you. I'm honored.
Audience. Yeah. That's it from my side. Thank you very much.
Thank you.
Thank you.
There's a question. Ali Aouni, go ahead.
Hello, everyone.
You can, if you want, to activate your cam.
Okay. So
just to see you.
Do you see me?
Yeah.
Using two cameras, so I think mine is not the right one, so I have to change the setting. Okay, so maybe I can keep this one. So I'm
just try, if you can introduce yourself.
Okay, so this is Ali Aouni. I'm associate professor at ETS Montreal from the University of Quebec. So I want to thank Professor Nasraoui for this great talk. I very much appreciate her current research work, which is also like related to what I'm doing. So we in my lab, so we apply machine learning, deep learning, and other optimization techniques to solve problems in software engineering. So we mainly look at data that come from software engineering, from open source projects, and you know, so now with the explosion of the number of projects that are available and data that are available on software engineering, so people care too much about explainability of the prediction models or recommendation models. So you know, in this area, so people are not just interested to say that, okay, so we recommend this change or we recommend you this product. So we want to know why this is recommended and why or how you come up with these recommendations. So, so even the models that are generated need to be faithful to the reality or to the domain knowledge or to the wisdom of the crowd. So one of the issues that that we are facing on that is how to measure explainability or how to convince that our model is explainable. So I'm wondering in your lab or in your research area, so are there any like measures or any ways how to quantify explainability and how to convince that your generated model is explainable?
Yes. So first, thank you so much. I reciprocate your thanks, and I'm glad you work on this. Actually, I may have seen some of the work I think that you have on software engineering. So you asked the $1 million question, Ali, because that is the hardest, one of the hardest challenges right now in our field is how to measure explainability, right? So I would say it would depend on the setting, where you are, the context, exactly how that recommendation is being used, and especially how you built your algorithm, right? So if we claim that we built in explainability, so what does the explainability look like, right? So for example, in our case, I showed an example where the explainability was based on like showing that there are many people who share your interests, let's say in a product that is recommended, who also like it, right? So that score, can you compute that, right? Can you compute that fact? And a lot of times, if you look at it, you can't compute. In fact, that's how we came up with the idea of explainability by design. So the explainability by design is being able to compute, pre-compute potential scores for explanation. So an item is explainable not by itself, but to a specific user, right? If there is enough evidence that justifies why that item would be relevant to that user. So if you're using collaborative filtering, it would be based on that algorithm. That's why I said it depends on the algorithm. So collaborative filtering says that if people, based on your shared interests with other people, right? If they like something, then you'll most likely like it, right? But you can actually compute that from the data, right? So the way we did it is we computed the probability, right? That the neighbors around a user, that means they share their interest in that space, right, in a common space, the probability that they will like a particular item, for example. Imagine that you can compute that. So, and then you can compute the expected rating, right? So the probability of each rating, not that they use it, but it's similar. And then you're able to compute the expected rating among the neighbors of that user, right? And then that matches, as long as it matches with the explanation, then that is a score. And what we did is we came up with something called mean explainability metric, right? And or mean explainability recall and precision, actually. And what they count is we take the top 10 list, the top ranked items, right? And we compute the explainability score. We have actually pre-computed the scores for each one of those items, right? And then for example, you can average those scores, right? To get the mean explainability precision.
Yeah, okay, thank you very much for your question. So yeah, I think the field is like relatively new, this kind of explainability thing. So, and maybe in the next few years we will have maybe much more people working on that, and we may have like more like systematic ways how to measure or how to better convince. So one of the issues that I'm currently facing with that is, when we submit research papers, we have to convince in a systematic way. So this is one of the issues that we are currently like facing, how to measure explainability. So yeah, I will read some more of your papers. So I think this is first time to me to see some of your work. So yeah, I'll have looked in deeper into your research, and thank you very much again for your response.
Thank you. Thank you for your question, and thank you for coming here.
Thank you very much, Mr. Ali Aouni. Okay, there's a question. No, I don't know. No, I know. Mr. Ali raising your hand. Do you have a question for another question for Professor Olfa?
No, I think I should hide my hand.
Okay. I have a question, Professor Olfa. What about do you consider what about partnership with the Tunisian research laboratories in these technologies? Do you think about that? Do you have projects, initiatives?
Yes, I would be very happy to do it. In fact, in the past, I did collaborate. I even helped to co-mentor a PhD dissertation, actually,
Yeah.
in Tunisia. But I'm honored to do it. In fact, why not? And we published together. In fact, was one of my top-rated publications that had most impact is with Kothayl Khribi. He was actually I co-mentored him for his dissertation, and then he visited as a Fulbright scholar.
Yeah.
And I believe I forgot where he is right now. He's in Qatar, actually. Yeah.
Yeah. We see that you help many Tunisian students in l'École Polytechnique and other places to find to continue studying research in the USA.
Okay.
Yeah. Ah, Mr. Ali, another. I don't know. Perhaps it's a bug or I think. I don't know. Do you have a questions? For
No, I think there's something wrong. I have to.
Okay. No, not care.
Sorry.
You know, I want to see a question from one of the women in the audience. This is women in data science. Come on, women. You can ask in French or even in Arabic. I can answer you.
Allez. Bon, je
I
vais
can
pas.
say the technical word in English and I can try to answer
Bon,
you. So please come on and
je
speak in French. I know the women, Tunisian women are
je vais les booster,
pretty,
Madame Wolf, je vais les
experienced.
booster. Bon, voilà, je vais. Ines Alay, elle va intervenir juste après.
Yes.
Donc, assistante professeure, je dirais, elle est LNC. Ines, est-ce que tu as une question? Est-ce que vous avez une question? Est-ce qu'on peut envisager un partenariat, un échange autour d'un travail, autour d'un projet qui concerne le contexte tunisien, le contexte technologique tunisien, dans le domaine de la data, l'intelligence artificielle, avec, je dirais, le laboratoire de recherche de Madame Olfa qui vraiment... Ah, ok, parce qu'elle est en train de parler. Je n'ai pas activé le micro. C'est de ma faute, je suis désolé. Et puis, je vous active un peu le webcam. Vous pouvez intervenir. Allez-y, Madame Inès. Allez-y, Madame Inès.
Alors, vous
Allez.
m'entendez?
Oui, bien sûr, évidemment.
Alors, bonsoir. Hi, Professor Olfa. It was nice to...
Oh, sorry, I missed it. Hello, Ines. It's nice seeing you in person and meeting.
Yeah, it's nice to see you also. And the presentation was great. Thank you for the presentation. So for my question, I will present my work and with my team. Actually, I work on optimization and operational research, not really on machine learning or deep learning, but I'm beginning on combining machine learning with optimization algorithm to optimize the results of machine learning algorithms. My students just started. He done his master's and maybe he will be in a PhD. So yes, it would be great if I another student. I have another student also that use machine learning algorithm to optimize the ant colony algorithm and helping ant colony algorithm to solve an academic problem, which is the knapsack, the multi-objective knapsack problem. So yeah, it will be great And ainsi, I will present that. We have a section which is artificial intelligence section for the engineer cycle. So we have a promotion at each year of 40 students which are engineer in artificial intelligence. So yes, it will be great, as Sami has proposed, to see if you have, if you need actually, yes, students in artificial intelligence. So we have at ANSI une filière IA en fait, une filière d'intelligence artificielle. Donc voilà.
This is a great idea. I really respect your work, Ines. And I believe actually the marriage between optimization and AI is not only important, it's essential. Actually, we use optimization for the fundamental.
I have just started
fundamental research without optimization, right? Because you can apply maybe AI without optimization, but if you want to create, right, you need optimization theory. And we do, and I'm very, very happy actually to help co-mentor and collaborate. Like, you know, not everybody has to travel, and not everybody has to displace themselves. You can do all kinds, the whole world right now collaborates. There are so many teams that are international. And you can give and create in your own country, and you can really do amazing things. Like I said, one of my top cited publications is collaboration with the student. I commented with Dr. Jemni, was his professor, and I just commented them, right? We published together, we did everything, and then he visited later as a Fulbright scholar, which is really an amazing opportunity. So it's very, very feasible.
Yeah, it will be great.
Yes, I'm happy to do it.
Thank you.
You're welcome.
Thank you. I want to ask a question from Salma Jamous. No, Salma Jamous, I want, because I made a very great talk yesterday about social media, and I want to start discussion between Professor Olfa and her about this kind of subjects. Salma, if you want to you can speak in French, huh? Salma. Salma Jamoussi. Ah, micro, ok.
Mais you have to, yeah.
C'est ma faute. Where is Salma? Ok, c'est de ma faute. Vas-y, Salma.
Bonjour, merci pour cette opportunité de prendre la parole avec la professeure Olfa. Nous sommes aussi très honorés et très fiers de voir des Tunisiennes aussi brillantes et rayonnantes que vous, Madame Olfa. Et en fait, la question que je voulais poser, en fait, c'est par rapport lorsqu'on parle de Artificial Intelligence Explainability, en fait, la plupart des cas, on parle de deep learning. How to make deep learning, for example, embeddings or systems or models explainable. Je ne sais pas si vous avez un petit peu vu ce volet-là, et si vous pouvez peut-être, comme ça en discussion, nous orienter un petit peu sur les directions à prendre lorsqu'on veut faire effectivement du deep learning interprétable et explicable. Parce que je travaille sur le deep learning, et c'est vrai que l'IA explicable, ça m'intéresse beaucoup, et je voudrais vraiment entamer ce chantier-là. Et voilà.
Yes, Selma, very, thank you so much. I reciprocate your thank you, and I'm very happy you're here. I appreciate you attended my talk. And definitely deep learning is here to stay, and there is already good research going on about adding explainability in deep learning, right? I mentioned one of our work that Khalil Damaq did with, you know, explainable music recommendation using a recurrent neural network. That's just one example, right? But there are other techniques that people are inventing For example, they use things called attention models in deep learning. They try to also like trying to find which weights in general or features are the most salient for explaining a particular prediction. So there is something called the influence function approach, which is actually influenced from statistics, and people have used it to try to find which features are explainable. And of course, there are the post hoc methods. I'm not a big fan of post hoc methods, but post hoc methods try to generate explanations after the fact. So after the predictions. Those work for any kind of model. It doesn't matter if it's a deep learning model or not deep learning model, right? So there is a vast amount of work already, I believe, in doing that. And even we are actually moving in that direction more and more.
Pardon, mais la plupart de l'interprétabilité au niveau de l'IA, est-ce qu'il est, parce que je suis en train de suivre un petit peu les recherches et j'ai l'impression que c'est plutôt par rapport aux résultats finaux du modèle de l'intelligence artificielle. Par exemple, comme vous l'avez mentionné, en clustering ou peut-être outliers, comme vous avez aussi expliqué un petit peu par rapport aux résultats que nous avons obtenus dans les systèmes de recommandation. Je pense que c'est la plupart des recherches qui vont dans ce sens, il me semble en fait. Je ne sais pas, est-ce que vous pouvez affirmer ou non cela?
Oui. Explanations can play an important role, of course, not just in recommendations, but also in classification and clustering, if that's what you're asking, right? So, for example, in classification, the fault prediction, for the robot, our project is a classification project. It's not a recommendation project. So I showed you some examples of recommendation, but sometimes we just build classifiers, right? So not everything needs a recommendation. And in fact, I have a student, Mariam Bougelben, who worked specifically on explainability and clustering in her master's, long time ago.
Ok, merci beaucoup, Madame Olfa. C'était vraiment un plaisir et un honneur de vous avoir entendu aujourd'hui. Merci.
Avec plaisir. Merci. Merci, Sami. There is another question. Sihem?
Sihem, professeur Sihem Jaziri. Allez-y, Madame Sihem. Votre micro est activé. Je sais pas, elle a perdu la connexion. Ah oui, attends, je sais pas. Ah oui. Hop, je trouve pas. Ah oui, Sihem. On vous entend pas, Madame Sihem.
Vous m'entendez maintenant?
Oui, le son, il est très loin, très très loin. On entend très peu, très faiblement.
Je ne sais pas. Maintenant, vous m'entendez?
Augmentez à la limite le son.
J'ai augmenté, mais...
Ah, peut-être il y a un petit problème de contact au niveau de votre micro. Allez-y, on peut vous entendre. Allez-y, posez votre question. Moi, je vous entends, mais faiblement. Je peux aider à la limite.
Ma question, elle est tout simple. C'est d'abord
Ah, c'est un peu mieux. Allez-y.
pour l'exposer. Et là, je voudrais aller directement sur ma question. Qu'est-ce que vous en pensez de l'algorithme qui sera destiné à l'ordinateur quantique? Autre chose, il y a beaucoup de travail sur les machine learning dédiées au fonctionnement des atomes et des molécules afin de préparer les machines d'apprentissage adéquats. Qu'en pensez-vous? Est-ce que
Vous...
I think I heard, and I'll just try to reword the question. It was very noisy and the voice was not good, like very low. But I think you were asking about the future for maybe for quantum machine learning.
Yeah.
In terms of explainability, right? I will tell you that at this time, quantum computing and machine learning is still in its infancy. It's in its very, very early stages, right? So until we have the science for machine learning in quantum computing, something that's proven, right, with the evidence, something that is reproducible, and where we really understand the models and how they work, right, especially not just the practice, but also the theory, right, which took a lot of time, long time, if you think about how machine learning, which is what's driving AI, by the way, right now, took decades, right, to really develop and mature. And hopefully with quantum machine learning, I hope that it will mature in a shorter time, right? Because I can't wait to put my hand on it and also work on explainability in quantum computing. But it will come. There is no question about it, right? When the time comes, the community will move towards studying explainability and debiasing in quantum computing, and it will open a new era. It's actually very, very exciting. I like your futuristic question, Sina. Thank you. And thank you for coming to my talk, and I appreciate your question. Does that answer your question?
Professor Siham? It's a technical problem. I think Ines Bouzouita, do you have a question? Ines?
Someone is raising his
Ah,
yes.
Okay. No, I don't see.
Donc,
I think Salma peut-être. No, same. Hop. No, it's, I think a bug for Salma Jamoussi. Do you have another questions? Ines Bouzouita. You want only question from women, Professor Olfa?
No, anybody can ask questions. I was worried because I didn't see the women. I thought it's women in data science.
Well, I think Yassine Ben Ayed, Professor Yassine Ben Ayed can ask you.
Absolutely, you are welcome. Marhaba, yeah, please.
Allez, go ahead, Yassine. Yassine Ben Ayed. Yassine. Professeur Yassine. Allez-y, on entend.
Voilà, donc merci pour la présentation qui est très claire et très intéressante. Bon, moi je travaille un peu sur la partie médicale, healthcare. Donc, comment vous voyez l'application de machine learning dans cet axe de recherche?
Yes, so thank you for your question, Yassine. So of course, that's actually one of the most popular areas where machine learning and AI is already being used, right, in healthcare. And I think I gave an example in one of my projects in our lab that worked on autistic data. That's an example showing, when you have medical record data mixed with other kind of data sets, what kind of things you can discover. But of course, it's one of the most thriving areas actually in healthcare. So this is something we don't really collaborate as much anymore with the people who do that, but we're open to do that in the future.
Okay.
Yeah, especially in personalized medicine. Yeah, especially I believe the biggest future is in personalized medicine, because personalized medicine is really it holds the future to cure a lot of the diseases that right now do not have any cure. Especially things like cancer and in the future Alzheimer and so on.
Okay, merci.
Merci.
Avec plaisir. And I'm going to put in the chat some of the links.
Okay.
information.
Okay, yeah.
I just need to.
Donc, Hossein Farhat, thank you for sharing link about your, donc, si vous avez des questions, n'hésitez pas entre-temps. Donc, si vous avez des choses qui arrivent comme ça, au fil de l'eau, profitez. Je vais demander à Madame Kauthar Boussem une question. Madame Kauthar. J'ai activé votre micro. Allez-y si vous avez une question.
Alors, je vais commencer déjà par remercier Madame professeure, en fait, Olfa, pour cette belle présentation. Je me présente Kauthar Boussam, en fait. Alors, moi, je suis docteur en IA de l'Université Paris-Dauphine et je m'occupe d'un master d'intelligence artificielle à Dauphine, Tunis. Je n'ai pas eu cette chance de continuer dans le monde de la recherche après mon doctorat. J'ai intégré tout de suite le monde professionnel. J'ai intégré Oracle pour concevoir, en fait, d'appliquer l'IA dans le monde de la comptabilité. Et c'est plus de la génération automatique des métalangages, en fait, la définition du métalangage. Ensuite, pour pouvoir justement générer en fait, des programmes qui ont la capacité de gérer la comptabilité selon les différentes législations. D'accord, donc c'est plus dans le domaine de la modélisation et des langages, tout ce qui est langage, modélisation, langage de programmation. Et je me pose la question, est-ce que vous pensez qu'aujourd'hui, on peut aussi appliquer le machine learning à ce domaine de comptabilité, qui est un domaine... Alors, il y a deux contraintes. Il n'y a pas uniquement l'exigence au niveau du résultat, mais aussi l'exigence... on doit justifier la règle qui est appliquée. Donc, on a deux volets à gérer. Et je commence à m'intéresser un peu au machine learning pour voir si on peut, exemple, imaginer ou une IA qui est capable de définir les règles comptables, en quelque sorte, de déduire les règles comptables et pour pouvoir accélérer les clôtures comptables, tout ce qui est réconciliation au niveau des choses que aujourd'hui, on passe beaucoup de temps pour réconcilier, les réconciliations bancaires. Mais ça reste toujours des techniques manuelles et n'utilise pas du tout d'intelligence artificielle. Et l'autre contrainte qu'on a, si on veut aujourd'hui introduire de l'intelligence artificielle dans ce domaine, on doit justifier, en fait, expliquer les règles qu'on utilise.
Oui, Kauthar, merci, Kauthar. I'm really honored that you are attending today, and I'm very appreciative as well. So for accounting, right? That's what it is in English, right? Accounting.
Right.
I'm not an accounting expert, but I can. I'm very, very optimistic that there will be machine learning algorithms, if there aren't already, right, that work in this domain in accounting, especially deep learning models. Which basically, remember, in your case, you're going to need to have a lot of annotated data, right? Inputs and outputs. So it is, if the input is like this, the output is like this, or the behavior should be like this, right? And so what the obstacle and the necessary, typically, right, the necessary prerequisite for most deep learning models is the existence of data. Quality, good, quality, annotated data, and a lot of it. So the more data there exists, the more likely that a model can actually learn from that data to come up with it. They will learn those rules that you just mentioned, right? But of course, to be able to make those rules explainable is a totally different story. That's the explainability part. So it's not going to be easy, but it's possible. So again, the data is everything. in this case. And I would be surprised if nobody tried at least simple white box models, so like without having to go to deep learning. I would be surprised. I would really be surprised if nobody has tried it. You know, like for example, using regression trees or random forests or something like that to be able to kind of reconstruct, you know, the outputs in accounting.
Peut-être la difficulté, en fait, c'est de comprendre déjà la comptabilité.
Yes, it's true. Yeah, yeah.
Ouais.
Usually
Les
when
données,
yes,
ouais.
yeah.
Les données sont propres. The advantage that we have the data is cleaned.
Yes.
And maybe the only issue is that people need to understand the accounting rules.
Yes, yeah. And probably the data might be private as well. I'm not sure, but I can think of there may be some privacy issues, right?
Right.
Yeah, so that's
the second
be,
issue.
Yeah, so that's going to be probably an obstacle at the beginning, right? But until people give out the data, it will be very hard. Or it could be that one of the, you know, the big player in accounting, you know, whoever has a lot of that data to kind of build these models, predictive models for the beginning, and then let's say share and open source just the model itself, not the data, so that people can transfer the learning, you know, and adapt it to their own data, which is what happened with ImageNet, you know, in the deep learning world with images and so on. If you think about it, you know, so Google does not have to give its entire public image data set or its entire, you know, web crawl data set, and nobody would be able to use all of it anyway, or even to load it or store it, right? But you can take the model that has been built on it, so it's called the pre-trained model, and then take it and apply it, you know, run really a few iterations sometimes of additional learning on your own data to adapt the deep learning model weights so that it adapts to your own domain. And I believe that's something that if it hasn't happened, it will probably happen most likely in that way in the future, because that seems to be the trend right now with image and text and everything.
Merci.
You're welcome.
Sami. Y a d'autres questions?
Do we still have some time?
Sami?
I don't know who else is raising their hand.
Ah oui, oui, je vous entends, je parle dans le vide. Houssem Farhat, you can ask your question if you want.
Bonjour, merci beaucoup pour votre présentation et votre initiative. Je trouve que c'est super constructive. Et moi, personnellement, je m'intéresse au deep learning et ce qui m'intéresse en plus, c'est tout ce qui est le deep learning et machine learning dédié ou industrie. Aujourd'hui, nous sommes en face de pas mal de problèmes dans le monde. Comment on pourrait déployer des modèles de deep learning qui sont profonds, qui sont costauds au niveau de volume et aussi même pour tout ce qui est computing. Ça veut dire que ça prend un peu de temps pour prendre une décision. Et quand on parle un peu pour l'embarquer, le domaine embarqué et déployer des modèles de machine learning dans l'embarqué, on a parfois des contraintes de consommation énergétique et un peu aussi le temps d'inférence qui peut prendre énormément de temps. Et là, ce que je pense, que je sais qu'un peu dans le monde, aux États-Unis, en France, en Allemagne, il y a pas mal de recherches qui s'intéressent au sujet et comment ils peuvent passer un peu des modèles à haute performance qui marchent super bien sur des cartes graphiques GTX et RTX ou quel que soit. Ou après, comment on peut le faire, comment on peut en faire pour les déployer sur des cibles hardware triptyque comme le TPU TPU Coral ou bien l'IG100NX ou des cibles hardware à basse fréquence ou à basse consommation énergétique. Et ma question, c'est est-ce qu'aujourd'hui, on pense à faire pousser ce domaine en Tunisie? Est-ce qu'il existe des recherches? Est-ce que la Tunisie, elle veut rattraper ce retard par rapport au monde où ils sont? Et même aujourd'hui, on parle des voitures autonomes, même si on dit on ne peut pas donner assez de confiance au deep learning. L'exemple de Tesla aujourd'hui, oui, avec Elon Musk, quand il dit nous pouvons pas ou nous pourrons passer au niveau 4 alors que jusqu'à aujourd'hui on ne sommes pas allés. Je veux savoir, en fait ma question c'est un peu aussi politique, la Tunisie, est-ce qu'elle peut aujourd'hui rattraper tout ce retard ou qu'est-ce qu'il faut faire tant que nous, par exemple, les gens qui s'intéressent à ce domaine, qu'est-ce qu'il faut faire pour qu'on puisse aller vers rattraper ce retard et aller vers au bout du domaine et prendre notre place dans le monde?
Ah. Big question.
Hossein, I hope you're not asking me that question because I'm a scientist. And when I wear my scientist hat, right, I remove my politics hat. And when I put my politics hat, it's better to.
Je vous comprends, mais en vrai, ce qui me pousse, moi, personnellement, c'est d'avoir que nous sommes capables de faire pousser les gens et faire des initiatives. Et là, à chaque fois, j'essaie de voir est-ce qu'il y a des gens qui sont aussi motivés pour même passer les règles politiques et faire des choses de notre propre main, de nos mains. Et voilà. Donc, c'est un peu ça, un peu plus. Et merci.
Hossein, vous êtes basé en France, à Nice, c'est ça?
Ouais.
Donc, ok, donc c'est pour ça que vous posez la question sur la Tunisie, parce que bon, je pensais que vous êtes certainement en dehors de la Tunisie pour poser cette question sur la Tunisie. Ok, bon, enfin, moi, ce que j'ai retenu la question, c'est l'utilisation, de deep learning dans le monde industriel, c'est ça?
Oui, on peut.
Voilà. Est-ce qu'il y a des use cases, par exemple, aux États-Unis? Est-ce que c'est un domaine qui se développe ou pas aux États-Unis? Ça, déjà, si on peut avoir une réponse de la part de Madame Olfa, c'est déjà, bon, voilà. Donc, déjà, voilà, une première information, intéressante. Est-ce que, c'est un domaine qui est censé se développer, censé être, se développer dans le futur ou pas?
Merci d'avoir encadré la question.
Est-ce que vous avez une réponse par rapport à ça, Est-ce qu'il y a de la recherche autour de ça dans le monde, Madame Olfa?
Sorry again. So speaking in English, and I'm very sorry for that.
Yeah, go ahead.
I think I'm an optimist, and I don't think that anybody is too late. It's just to accept that somebody is too late to even do something, right, or start. It's just insane. It doesn't make any sense, and it's very, very defeatist, and it's not human. I think. I believe that it's never too late. That if Tunisia wants to, catch up and do advances, it can. Tunisia has something that is really very, very special. It's the capital, actually, the human capital and the intellectual capital. I mean, we produce an amazing talent. And you see that some of the countries that weren't really producing that much before, now they have, different kinds of incubators, and they started mostly from, take the example of India, right? The outsourcing movement, right, has, caused a lot of these big companies, especially IBM and Microsoft and Google and so on, to open branches there, right? They have engineers working there. And then from there, that most of those places, they were actually next to universities, like Indian Institute of Technology, right? Which is one of the top, and they have different campuses. And that has generated this amazing synergy between their universities and these labs like IBM Research. My advisor was from India, L'Encadreur, my PhD, my master. He moved to India, actually, and he was a manager in IBM Research. He's one of the big directors there. And now he's a dean. He's a dean of research in some university after he retired, right? Just to give you an idea. So I think that probably And I know it seems like it's really hard to catch up, right, with this world. But we have the talent. If we have the will and really a good way to negotiate and help these big companies, if possible, right, open even small branches next to our best universities. I believe that's like the steroids, when you in sports, which is illegal in sports, but in this case, it's legal. It will definitely put us on the map, and it will completely change where Tunisia is. I can guarantee you in probably less than 5 years, in 5 years, it will change completely everything, the education, the research, even the jobs, of course. So just one of these, if one of these open, one of them, IBM, Microsoft, or the big labs, it could be anything. It could be Pandora, it could be Amazon, right? A research lab or a production lab right next to a university, and then you will see the internships starting to go on. You'll see the researchers working together, right? And it will put us on the map, and we will be able to catch up very, very quickly. And we are doing well, I believe, in AI, I think, but in some domains. We have startups already, and I think Sami is more familiar with those, right? But yeah, we should be optimistic.
Yeah, you must. You best. Perhaps a question from Dr. Qusay Mrabit. Qusay, je vais activer votre micro. Allez-y si vous avez une question. Je sais que je suis un peu brutal, mais voilà, c'est juste pour vous donner envie de poser des questions. Docteur Qusay? Ah. Je sais pas, il est parti.
Bonjour Sam, je peux poser une question?
Ah, allez-y, Madame Fez.
En attendant que le participant puisse être prêt.
Je pense que
donc, très bien. Bon, merci Olfa pour la présentation que je trouve très intéressante et pertinente. Nous avons fait les 2 jours avec toujours de belles présentations dans le domaine. Et là, on a plus valorisé l'implication de la femme dans plusieurs domaines appliqués de l'intelligence artificielle. Et aujourd'hui, on continue. C'est bien, certes, les systèmes de recommandation, on les voit partout appliqués à plusieurs domaines. Moi, j'ai travaillé beaucoup, et notamment dans les mêmes conférences Rexis et tout ça. Donc, j'ai vraiment aussi des papiers là, dans ces conférences que je trouve très intéressantes et pertinentes. La question, c'est qu'aujourd'hui, nous, on a essayé de vulgariser un peu l'IA et de dire que ce n'est pas quelque chose de difficile, il faut l'appliquer. Après, on fait appel à des gens qui travaillent sur les techniques et les modèles. Les systèmes de recommandation, bien que quand on les voit, ils sont appliqués dans plusieurs domaines. Et cependant, par rapport au contexte tunisien, si on revient au contexte tunisien, quand on parle de système de recommandation, très peu de gens l'utilisent. Ou ils sont beaucoup plus, on focalise sur machine learning, sur le deep learning, sur des systèmes d'IA, mais alors que les systèmes de recommandation sont des parties prenantes très intéressantes. Et c'est comme si on a l'impression, les systèmes de recommandation, c'est pour les YouTube, Netflix, des choses comme ça. Oui, c'est vrai, c'est très utilisé. Mais quand on regarde un peu aujourd'hui Amazon Go, Amazon, c'était parmi les premiers qui ont travaillé sur les systèmes de recommandation. Et aujourd'hui, le système tunisien, dans les grandes distributions, dans l'industrie, etc., pratiquement pas du tout utilisé les systèmes de recommandation. Alors qu'on a le contexte Web Mobile et tout ça, et on peut vraiment l'utiliser pleinement parce qu'au côté technologie, au niveau de la Tunisie, on a toutes les compétences. Nous, sur les papiers, la recherche scientifique, on n'a fait que de ça. Moi, je travaille sur les recommandations des documents pédagogiques, sur les recommandations d'une application tunisienne comme Netflix. On a travaillé beaucoup de ça sur les articles scientifiques pour faire le matching entre le profil. Mais c'est vrai que si on regarde à une autre échelle de la chaîne de distribution, on ne trouve pas du tout ce genre d'application. Donc la question, c'était de sensibiliser, parce qu'aujourd'hui c'est une belle occasion de parler autour de ça, et moi je crois beaucoup à ça. Comment peut-on simplifier, vulgariser et dire que si on fait des choses appliquées, c'est vrai qu'on va avoir que des choses fructifiantes, des résultats fructifiants à la fin, prometteurs. quel serait le message ou quelle serait aussi la coopération en tant que Olfa, vous êtes professeur dans ce domaine appliqué, comment vous projetez demain pour la Tunisie? Quel genre d'application peut-on mettre en œuvre, à part votre concadrement, master et thèse et recherche, ça c'est le côté applicatif justement. Comment peut-on envisager ça? Et quelles seraient les recommandations que vous pourriez donner justement aujourd'hui à des gens à nos chers participants? Vous pouvez parler en anglais, hein, c'est pas grave.
Oui, thank you. Merci, Erin. Merci, and thank you for attending and I reciprocate your acknowledgement, really. And I just wanted to say that really there is nothing stopping these industries, right, from applying recommender systems other than really just complacency and thinking that if it's working, why fix it, right? That's maybe there is a mentality like that. But the problem with the good thing with the recommender systems is actually they do help. They are proven to help improve the user experience, right? Especially on online platforms. And I'm not just talking about e-commerce. There is already stuff going on, in e-commerce, but there is also like think about the news website. We have so many news. Everything right now is on the web. All the different media, the radio and news, all kinds of, I cannot even start, I'm actually very, very surprised if they're not using recommendation systems, because right now, all of these companies, they can literally take, deploy a recommender system tool almost like out of the box. They don't even need to have that much. They may need maybe 2 engineers, right? And they can put it up. They can collaborate with people. They can collaborate even with me. If I'm in Tunisia, I can work, with me and my students. This is something that's actually right now becoming very acceptable in the United States. I do get, sometimes, calls from different, big industry. They're trying to start these alliances, between even Amazon. I talk with them sometimes. And even professors in the United States, believe it or not, they also do. I don't do it yet, but people do consulting. You can spend 1 day per week just working with industry. Or you can have maybe your student, right? We can co-mentor a student, maybe, or an engineer. We can co-mentor an engineer. That's how the alliances between industry and universities right now in the US, they work like that. So the engineers will be either in your lab or in the industry, right? And the researchers also same thing, right? And they work together to solving a problem as if they're working in the same lab. And it can be completely virtual, like they don't have right now. The people who talk to me here, they're actually remote. You're not going to even travel or go anywhere. So you can work on everything. But again, I think there is a huge potential. If it's not used, I would be really surprised that it's not being used. It just doesn't make sense.
Exactement, vous avez raison, parce qu'en fait, il reste encore cette collaboration entre l'industrie et la recherche qu'on souhaiterait plus valoriser. D'ailleurs, ce serait intéressant de prévoir des choses comme ça, des sensibilisations de séminaires dans le sens où impliquer la recherche et l'industrie. Très peu aujourd'hui, je parle au contexte tunisien. On a quelques recherches appliquées dans le cadre de projets Mobidoc, mais ça reste quand même très restreint. C'est pas ouvert à tout le monde, c'est pas quelque chose d'automatique. On n'a pas des départements d'études de recherche dans les grandes entreprises. Et je pense qu'il faut beaucoup plus trouver les moyens de les rapprocher pour justement concrétiser un peu ce qu'on fait au niveau de la recherche, que ça soit vraiment appliqué et bénéfique pour les deux. Voilà. En tout cas, merci. Je suis d'accord avec vous et j'espère qu'on aura l'occasion de collaborer ensemble.
And Reem, if I can follow up, just to tell you the reason why I answered that way is this idea of collaboration between industry and academia in the United States. It was started by co-funding from the government. It didn't just happen like that. There is always somebody who's going to encourage. It's like if you have 2 kids that don't want to play together, right? Who's going to make a difference? It's the parent. They come and they say, okay, if you play together well, I'm going to give you ice cream and I'm going to bring you, buy you a new toy and take you on a trip, take you to the movies or whatever, right? It's the same thing.
Yes,
so the government here right now, they even opened 1/3 a new directorate in National Science Foundation. Just this week, actually, we got the announcement. specifically for partnership between academia and industry. They had different projects before, but now it's gonna like explode, and they give you specific money, usually that will fund both the industry and the people in academia, and they can do this. There are so many. I said there is a lot of talent in Tunisia. There are many labs, and I'm sure there are labs who work on personalization because I collaborated with them on recommendation systems for e-learning, for example, and I'm sure there are others, right? So if the government makes an initiative like this, it's usually smaller funding, by the way. It's not very big, this kind of funding, because it's a collaboration.
Okay, thank you very much. Merci beaucoup. Thank you.
You're welcome.
Nice to meet
you. Merci, Madame Faiz. Je sais pas, Manel, vous avez une autre question parce que vous levez la main.
Oui.
Il y a deux personnes qui ont levé la main.
Allez-y, Manel.
Okay, so Professor Olfa, you know, I attended the presentation by Khalil Damma at Rexis 2021, and I'm working on something close. So the paper in general is about debiasing explainable pairwise ranking for implicit feedback. And we know pairwise ranking can be starting from BPRMF to others. And I see that the main focus of the paper is using BPR. My short question is, maybe it's a designer choice, experimental choice by you and the co-authors to work on BPR. May I ask you, why did you choose specifically BPR and not others? And then I will let you know why I'm asking this.
Well, BPR, this was for implicit data, right?
Yeah.
And BPR, at the time we started working on this, like a few years ago, and still really, BPR is the state of the art.
Yes.
It outperforms almost every model. In fact, it's one of those models that is recognized in industry, like openly for ranking, because that they need implicit feedback models in industry. Actually, it looks like they need it even more than the traditional, explicit feedback, like ratings and so on, because most data is implicit, right?
So
yeah, BPR is one of the winners, really. It's one of the state of the art. So advancing the state of the art, obviously, that is something that's very attractive. Does that answer?
Right. Yes, kind of. I will tell you, I also use BPRMF in addition to others in my experiments. And from my experiments, I found that BPRMF, the one called the state-of-the-art collaborative filtering technique, is not that strong. It's weak. And I see also in the paper how you mentioned the exposure bias. And this is because of the popularity bias. In my experiments, I don't touch the algorithm itself, but I work more on the inputs. Specifically in this paper, I do synthetic data generation. It turns out in BPRMF, compared to implicit MF, compared to simple item KNN, user KNN, and others, is the weakest. What I mean by weakest is that it was too sensitive, and probably I destroyed a bit the long tail distribution, that BPRMF is not performing as the strongest baseline as it should be compared to the others. So, and now I see you, thank you, you put the links. So I said, my paper was about privacy and other stuff, and suddenly I see a strong behavior of BPRMF specifically that I have to explain. So it becomes explaining the output of BPRMF rather than synthetic data generation. So my experiments now with BPRMF, would you recommend me to test, or do you have any idea if there is other recommender system algorithms that do have this kind of sensitivity for the item popularity? We know it's a long tail distribution, but it seems some algorithms are more sensitive compared to others.
Yes, that's actually a good direction to compare algorithms. So I see where you're taking this. You're basically trying to compare the algorithms before you're debiasing. Yeah, and whereas in our case, we said, okay, we're going to take the top algorithm, right, the state of the art, and we're going to make it debiased, right, and explainable, which is a totally different philosophy, right?
Yes.
But what you're doing is, of course, extremely important, because that is actually, we spend a lot of time also at the beginning, trying to look at different algorithms and how they perform. But I think the community is not doing enough of it, and everybody, most people are inventing new algorithms, which is fine, right? Especially if you extend like a state-of-the-art algorithm. But I think we will learn a lot when you finish your research, and when we look at, like, especially when you publish this, I think it will be very, very informative to see how different algorithms perform. Like, if we don't change them, right?
Yeah.
How do they work, right? Or how is their maybe their fairness, right? I don't know. The transparency is different, because that's a different story. Some of them are white box, some of them are not, right?
Exactly.
But I think you're on the right track. I would definitely be interested in reading your publication. Yeah.
Thank you. Yeah.
Thank you. Je vais donner la parole à Madame Olfa pour la dernière. Je vais poser la dernière question et bon, on va arrêter parce que je dirais il y a le docteur Inès Alaya juste après. Il a une autre session. On a pris beaucoup de retard pour elle. Quel message vous passez, je dirais, aux jeunes Tunisiennes aujourd'hui, Madame Olfa? Comment vous voyez un peu l'avenir? Qu'est-ce que vous donnez comme conseil, j'irai, aux jeunes Tunisiennes aujourd'hui qui se lancent un peu dans ce domaine-là, et quelles voies doivent suivre pour, j'irai, réussir une belle carrière?
I would say it's a very, very good domain. Obviously, I'm not the one to say this. You already said it. There is a big future in it, right? And you can prove yourself. You need to prove yourself, really. I mean, here, the way you prove yourself is typically, right? Of course, either you publish as if you're an academics person, right? Or you publish your software, right? You develop something that works, and then you publish it. You try to, for example, compete in the international competitions. There is something called Kaggle, which many of you have probably heard of it. Kaggle competition. I highly recommend you compete in them. There is nothing that's holding you. You can do this. You can do it as a project, and maybe the universities, like the professors, can try to count it as like part of the credit towards success, as almost like a project or exam. And I'm looking for Kaggle right now, just to put in the link, just in case you didn't know. And this is the best. Even my students in my lab, I highly recommend that they do it. In fact, I encourage them and I mentor them as needed. Sometimes they don't even need me, right? They go on and they compete in these competitions. They learn a lot and they win medals sometimes. They become famous. And you can't imagine how much those people are solicited. And when you see, and these companies start seeing these winners, let's say from a particular country, let's say from Tunisia, right? I can guarantee you that's the best way to attract, and also papers, publications, that's the best way to attract these companies. Like I mentioned, that solution where we will have these small, outposts, like a small Google campus, let's say, imagine, right, in Tunisia. Right? But that needs a lot of politics, right? Lots of diplomacy, right? So that somebody needs to be working, with the embassy. I don't know where is our diplomacy right now, but both embassies here and there, right? I believe that is possible, but we need to build the reputation. We need to show them the talent, right? We have the talent. Now we need to show them the talent. You show the talent by, like I said, competing in these international competitions and then publishing your code. Make sure, publish your code on GitHub, right? The code, the winning solutions, they're very, very highly downloaded. They're very repeatable. Yeah, and then what else? Working in teams, teamwork, being open-minded, really dedicating yourself to working. Like literally, your life should become part of your work and your tinkering with the software, right? Unfortunately, at the beginning, to make your name, right?
Thank you.
Yeah, I don't know. Just I think this is an ongoing conversation, right? But again, also be the shining star. Even if you think there is darkness around you, right? Be the one. You should be the star, and you should light. You should contribute with your light to light everybody else, right? If we all do that, we will be in a much better place. Yeah.
Thank you, Professor Olfa Nasraoui. Nous sommes vraiment ravis. Pour nous, c'est l'après-midi, fin de journée. Pour vous, c'est le matin. Merci, j'irai. On a eu beaucoup d'échanges et avec le report et tout ça, vous avez un agenda très chargé cette semaine et malgré ça, vous avez vraiment fait les efforts, insisté pour que vous participez à cet échange assez intéressant et riche avec les Tunisiens et les Tunisiennes et c'est magnifique et on vous souhaite toute la réussite et tout le succès aux États-Unis et encore soutenir un peu notre jeunesse pour aller encore plus loin dans la recherche et dans la science et surtout s'exprimer librement dans ses recherches et dans ses motivations, ses envies, j'irai toujours autour de la recherche et surtout voilà, qu'ils soient toujours sensibles à leur pays, ils ne tournent jamais le dos à leur pays, ils soient fiers d'être tunisiens.
Yes, thank you so much. Thank you. It was my honor and my pleasure.
Thank you so much.
And thank you for the great work you're doing as part of Re Connectt too.